Hi there, in this video I'm going to do two examples of inclined plane questions. So the first question we have talks about you holding an 85 kilogram trunk at the top of a ramp that is sloped at 35 degrees to the ground. You lose your grip on the trunk and it begins to slide down the ramp. They then give you that the coefficient of friction between the ramp and the box is, or the crate or trunk, I guess, is 0.42, and the question wants to know what is the acceleration. All right, so we'll set up our question. This is our very similar setup that we're going to usually have for these. You would have been, well, let's put in where gravity is straight down. So there's our FG vector. And when it slides down, this is going to slide down the ramp. So if it slides down the ramp, then friction is going to oppose that. In this case, friction will be up the ramp in the opposite direction to the direction it is moving. Nobody's pushing it, so there's no applied force. So I don't want you to think this arrow is an arrow that's acting on it, right? But what makes the crate fall down is part of gravity. It's not all of FG, but every time you do an inclined plane question, you're going to draw an arrow perpendicular to the plane and an arrow that's parallel to the plane, and you're going to break FG up into those components. Whatever angle you have here is the angle there, so it's 35 degrees. I will call this FG perpendicular because it's perpendicular to it. This vector will be FG parallel. It is down the plane, so it's the force that's making it go down the plane. Okay, so we are almost ready to start the question. I'll draw a couple of more vectors that are, or at least one more vector on here. The normal force on this crate is the parallel or perpendicular to the surface. This is the F capital N, the normal force. The normal force in this case balances FG perpendicular. Those two balance each other out. All right, so the only information I haven't included here yet was the mu is 0.42. And the question's asking for what's the acceleration. Okay, so to get an acceleration, I think I need F net, because I know F net is mass times acceleration. And I know the mass, it's 85. So if I can figure out F net in a different way, I'm good to go with this question. So I know F net is the sum of all the forces on an object. So in this case, F net is what are all the forces acting on it? Well, you have FG parallel down the plane. So we've got an FG parallel. And we also have friction up the plane, FF. And those are the only two forces acting on it. So if I can figure out FG parallel, I'm good to go. And if I can figure out FF, I should be fine. So that's what we're going to try and figure out. So FG parallel is it's a component from gravity in our triangle. So we need to take our gravity, FG, this is mass times gravity, so that's 85 kilograms times 9.81 meters per second squared, and that comes out to 834 newtons. Now to get FG parallel, that's my hypotenuse times the sine of 35 degrees. So this guy is 834 times the sine of 35. It comes out to 478 newtons. That's the part of gravity that's down the plane. So you got a 478 down the plane. Now we need to figure, so now we know FG parallel is 478. But wait, I need to think of direction. That 478 is down the plane, so I'm going to make it a negative 478, and I'm going to make it a negative 478 here. Now I need to figure out friction. The friction, FF, we already know how to get friction. I'll move this around a bit. To get friction, you do mu times the normal force. All right, we know mu, it's 0.42. Let's see if we can figure out what the normal force is. According to this picture, the normal force should balance FG perpendicular. So I'm going to figure out FG perpendicular. It is the cosine of 35 times the weight instead of the sine of 35. So I'm going to take my 834 newtons and I'm going to multiply by cos 35, and that's going to give me 683 newtons. So that would be in a downward, perpendicular to the plane. And if it's 630 or 683 down, then Fn has to be 683 up. All right, so no problem. We get 683 up. So that Fn, if you can follow my little arrow, is going to go right in there. So we know mu is 0.42, and my Fn was 683 newtons. Mu doesn't have a unit to it. So my friction comes out to be 287 newtons when you multiply those. Now, what's the direction of friction? Looks to me like I drew it up the plane. So I think that's a positive number. So I'm going to leave it as a positive. You're going to put 287 right in here. So 287. We now know FF and FG parallel. I now have F net. The total force is the sum of those two, where one is a positive and one is a negative. And that comes out to a negative 191 newtons. So that's down the plane. Okay, so negative 191 newtons is the net force. I said here that if I knew the net force and the mass, I can figure out that acceleration. So that's our last step to do. The acceleration is going to be F net divided by mass. So we take F net over m. My F net was 191 newtons down the plane, so negative 191 newtons. My mass was 85 kilograms. And so I get an acceleration that is a negative 2.2 meters per second squared, which means instead of writing the negative, it means 2.2 meters per second squared down the plane as my direction. Alrighty, let's try another example and see how it works. So, example 2. If you're pulling something up the incline instead. So we have a slider or a sled, a person on a sled. They are 82 kilograms, including the sled, and they're being pulled up just a small incline of 6.5 degrees. So what is that going to look like in terms of vectors? We'll draw our triangle. You have an object, doesn't have to be accurate. Right. We have gravity straight down, that's FG, same picture as before. We have two components of gravity, perpendicular and parallel. I will call it FG perpendicular, FG parallel. There's a normal force, same picture as before. Now in this case, we have to think which way friction is going to be. There's a force that's up the plane and that's going up the plane. So we've got this FA. It wants to know the tension in the rope. So this is an applied force up the plane. And since the person is moving up the plane, then friction is fighting you. So this time I will draw frictional force backwards down the plane. All right, so we've got lots of forces on this object. Since they gave us the mass, well, let's focus on what we're looking for. What is the tension in the rope? So we want to know FA. That's what we're trying to solve. This is the big question. They gave us a mu of 0.1, and they gave us a mass of 82 kilograms. We should be able to figure this out. Alrighty, so how do we go about getting FA? Well, I know that my net force is 0. The reason I know my net force is 0 is because they said you're pulling it at a steady speed. If you're pulling it at a steady speed, then it's a constant speed. If your speed is constant, then that means there's no acceleration. And if acceleration is 0, then F net is 0, because it was equal to ma after all. So if that's 0, the whole thing's 0. So there's no net force on it, but there's lots of forces acting. But if there's no net force, that means they cancel out. So the other thing for F net, I told you in the last example that it's all the forces that are added up in the same direction. So the forces I have, I'm just going to circle them in blue. I've got a FA, I've got friction, and I've got this part of gravity. that I have to add up. So FA plus FF plus FG parallel. Now I recognize some of these are going to be negative. FG is going to be a negative. FF is going to be a negative. And hopefully my FA will be positive. So just like the last example, I'm going to work each one of these out separately. So FG is mass times gravity. So that's 82 times 9.81. So when we work that out, I get 804 newtons. If it's 804 newtons down, this guy is going to be the sine of 6.5 degrees times that. So it's 804 times sine 6.5. So this is a smaller number. It's 91 newtons. That's down the plane. We're going to need the perpendicular one, so we might as well do it right now while we're here. That's 804 cos 6.5. So the downward component is, or sorry, the perpendicular component is 799 newtons. Okay, so this negative 91, that's FG perpendicular, or sorry, FG parallel. So FG parallel, I've got this number in my formula, negative 91. I already knew FNet was 0. We don't know FA. Boys, we're getting close. We just need FF. So the frictional force, if we remember, frictional force is always equal to mu times Fn. Mu is 0.1, and Fn is the same as Fg perpendicular. So this 799 down is 799 up. So 799 newtons times 0.1 is 79.9, so we'll round that to 80 newtons. Thinking of my direction, it's down the plane, so that's a negative 80 newtons. So I'll put negative 80 in here. So we can figure out the applied force on this by taking these two terms to the other side and subtracting them. So FA equals 0 minus a negative 80 minus a negative 90. So those all become positives. 80 plus, I changed that to 90, should be 91, my apologies. 80 plus 91 will give us our applied force. So that's 171 newtons is FA. That came out as a positive. I like to just double check that it should be positive. Okay, looks like it should be up the plane. That's the way I drew it. So 171 newtons up the plane is the answer. That's the applied force on the sled to keep it, to have it go up at a steady speed. Okay, so with those two examples, hopefully you can do lots of problems of your own.